On this week's NFV and SDN Reality Check, we talk with InterDigital about some of the work it's doing with software virtualization in support of 5G technologies.
Today's episode is brought to you by Telecom Careers, the #1 global telecom and wireless job board, telecomcareers.net.
Hello and welcome to this week's NFV SDN Reality Check. I'm your host, Dan Meyer, Editor-in-Chief here at RCR Wireless News. Thanks for joining us this week. This week, we are joined by Dirk Trausten, who's the Principal Scientist at InterDigital, to talk a bit about the company's moves into the virtualization space and get their views on the general view of the general NFV SDN market. So hey, Dirk, definitely appreciate you taking the time today. Thanks for joining us.
Thanks for having me. Thanks for having me.
Well, maybe let's start off with that. Obviously, we've covered you guys quite a bit in the past. You guys have done a lot of work when it comes to 5G and technologies and patents and things like that. I guess maybe get a little overview from you guys on the company and maybe your moves, I guess your views on the world of virtualization, what your guys' view on that new movement is.
Well, the way we look at virtualization is it's quite a long journey that's now come down from, essentially from the 70s where virtualization was introduced as one of the concepts. It's not really something new. We've seen this in networks as they are and built today. New technology developments in hypervisors, containerization, etc., and recent standardization efforts just pushes things a little bit more in the limelight, and it pushes it into functions that previously hadn't been virtualized, which is really one of the new things really. Some of the things do get qualitatively and quantitatively better. You can virtualize functions quicker. You can migrate functions quicker than it used to be. You can boot up resources quicker, etc. So that kind of increases applicability in certain scenarios. But and again, generally, it's a long journey. We've come a long path, and we see it now finally applied in the telecommunications industry.
Yeah, that's a great point. You're right. I mean, obviously, the virtualization world has been around for a long time in the data centers and the IP and IT world and stuff like that. But it does seem like, again, for the telecom space, perhaps a bit new. But again, it does seem like that the telecom space can learn a lot from what's happened there in the past. So it sounds like you guys are kind of doing a lot of work in terms of that. I know, you guys are doing some work, I think, in this acronym soup. I think it's IP over ICN over SDN work. Can you, I guess, maybe describe a bit about what that is and what you guys are looking to do with merging all those different technologies, acronyms together in terms of the telecom space?
It's a good example for the flexibility you can get if you start mixing virtualization techniques, software-defined networking techniques together, and use some of the advances in relatively recent research, which is the ICN part in the middle, to provide IP-based services that have a very different qualitative and quantitative experience and performance. And if you start at the bottom, we start at a story where we see operators moving to SDN-based environments, and that's where we're building on. SDN allows you to separate really nicely what's happening at the control plane from relatively simple data planes. And that's where the ICN part comes in. Information-centric networking has been researched for now about 8-9 years in public funding. Maybe quite some advances in with respect to the routing solution have been developed. And generally, as I relatively small summary as to what it can achieve with ICN is a more flexible routing. And so we position ICN on top of SDN as a routing innovation to change the way flows are aggregated and managed in an SDN network. On top of that, we are essentially restoring the IP experience. So ICN has been researched as a new way of doing applications. And if you write a new POP-SOP application, the experience might be better than it used to be before. The problem, though, is, and which makes this a more evolutionary story, the way we approach it is, that a lot of the application developers, obviously, they like to use their frameworks and their protocols that are out there. Therefore, changing applications as well as changing user equipment is a very, very hard sell. So with the IP, the beginning of that IP sequence, we are really allowing normal IP services to run over a routing substrate that is significantly more flexible, executed over a standard SDN hardware. And some of the qualitative benefits you're getting from this, and quantitative as well, because the gain is quite significant, is the introduction of multicast and HTTP scenarios. So what we mean by that is one of the issues you have because of the change from typical IPTV type of scheduled viewing to personalized YouTube and the Netflix type of experience is the proliferation of HTTP unicast. Everything is delivered by HTTP, and that means everything comes individually to you. even if now a number of people are watching the video at the same time, simply out of coincidence, you happen to watch the same video as I do, we don't know each other, it's not scheduled, it cannot be delivered in the solution is to reintroduce multicast by capturing similar or same responses to HTTP requests and sending them back via multicast. And that results in a very significant multicast gain in networks as one example of the quantitative benefits you're getting out of this. It's a nice example of how to use software-based. Now, everything is software-based. Cloud is software you can put in the cloud in terms of route calculation, standard SDN data plane switches that are used, and intelligent software around the network.
Yeah, and it's a timely example as well. I mean, obviously, video is a big part of kind of the telecom space right now, and especially in the mobile industry, a lot of operators are trying to figure out their video strategies, and new services being launched along those lines as well too. So it does seem like something like that, definitely very timely when it comes to kind of where we're at now. I guess, how far along in the development phase are you with this technology? Because it does seem like you are merging quite a bit there. Again, a lot of the stuff has already been out there, but it seems like you guys are putting together a lot of pieces. How far along the process are you guys in getting this technology and this platform rolled out?
We have a first prototype that we are demonstrating to the funding partners. That's a publicly funded project in the EU that's funded by the European Commission. So we're first demonstrating that to our funding partners there, and we're planning public demos for the next year in various occasions where we demonstrate, in particular, scaled up benefits. Which obviously in trials is a little bit difficult to do. So we're trying to scale this up through cloud resources in order to demonstrate the benefits. The software, even though it's a prototype software, runs at a pretty impressive scale. So it will be able to deliver video experiences, etc. Even though it's not a hardened product yet. We're also looking into the relevant standardization efforts to be kicked off for this as well, which directly aligns with other improvements that you're seeing in the SDN space. So we're piggybacking again on the SDN story there with that. So in particular for a publicly funded project, actually we're very far down the line and pretty quick and want to demonstrate and trial as quick as we can.
Got it. Now, obviously, you kind of mentioned the standards issue there. I mean, it does seem like what you're bringing to market also will probably require quite a bit of cooperation, I'm guessing, with other players in the space. And that's something we've talked about a lot on the show, is the fact that standardization and just be able to work with other players when it comes to this move towards SDN and NFV is a very important part of this. But perhaps we're still a bit early in the process. I mean, what's your view on kind of where we are in terms of that work and making sure that everybody kind of is playing on the same page, or at least is sharing the ideas that allow all this to kind of work together in the end story, that make sure that the operators, once they deploy these technologies, can actually get support that they need, and the stuff all kind of works seamlessly together. How far are we along those lines, do you think?
There are quite a lot of the invariants in a way are actually quite well fixed. OpenFlow allows you at least to run relatively simple rules in an SDN switch, and we've done that quite well. We're getting the software tools ready for configuring the actual SDN switches. I think also the way we try to position those, and again, it's an example of how you utilize the separation between the control and the standardized data plane, is to position what we do as an innovation as very concrete software extensions to an otherwise standardized system, so that the actual changes to the standard basis is minimal to, well, hopefully actually non-existing. Mm-hmm. Right, so it's really utilizing the innovation as we standardize them today. I think where the flux is a little bit bigger is in the virtualization space and the NFV space. Right, when you move away from the actual routing fabric, the actual forwarding fabric, to the computing fabric, and there's likely to be still quite a little bit of flux when it comes to the integration of computing resources. Something that we are again trying to tackle in the efforts we're doing, because it allows you to relocate computing resources relatively easily. What we are trying to do is stay entirely at the IP level. Mm-hmm. So move the simplification of routing and the even acceleration of routing changes under the actual IP abstraction, and therefore very little changes required on the top. So if you're a web server on our system, you wouldn't really notice that you're running on an improved system until suddenly your server appears much quicker than it used to be before. So there is no real from a standard perspective, change required at the level of the services, which is exactly one of our objectives, to circumvent that we have to, and to avoid that we have to run to standardization bodies for all of these kind of things.
Yeah, that's probably a good way to do it, because again, I think we are kind of definitely in the middle of this standardization bodies and things like that working together. I mean, if you can avoid that altogether, that'll give you a year or two head start probably on getting this project out there. So that's probably a good way to look at it. So that's a good way to tackle that.
I think the other thing that this work partially feeds into is an even bigger story to look at, in particular, what we call multi-tenant control. Mm-hmm. So how do you move from a relatively simple, I'm not saying that SDN environments are very simple to control, but if you deal with one technology, that's okay. If you look at some of the more advanced 5G scenarios that are out there, that do include environments that not necessarily will be SDN enabled for many years or ever. Not to mention satellite environments where SDN has not seen any proliferation, building scenarios. So you see a lot of smart city and smart building scenarios, and everybody seems to forget these control systems are nowhere near software enabled. They won't be SDN enabled, and therefore controlling the communication infrastructure at the operator level and the building infrastructure towards the unified service experience is a very difficult problem. And that's where I see most of the efforts in standardization really have to focus on how to make multi-tenant control work, what are the control frameworks that abstract even more from from OpenFlow nowadays in the SDN world towards a control framework that can indeed incorporate building infrastructures, IoT infrastructures, and an SDN infrastructure, right? And that's partly the bigger story that we are trying to build with this as one demo of how this would work maybe in an SDN environment, but some of the methods in a combined environment of SDN and non-SDN would look significantly different.
Yeah, that's a great point. Yeah, I mean, obviously the orchestration aspect of all of this and getting everything to work, whether the legacy equipment, obviously, I mean, telecom vendors or operators are not going to get rid of all this legacy equipment overnight. I mean, they might start replacing it eventually, but there's so many things out there that work well and are probably not going to be replaced. Like you said, they're going to be out there forever. But you're right. But then you're layering in this virtualization world and being able to get those two to talk together. That is definitely going to be the big challenge for a lot of this, is making sure that at the end of the day that those things are working together and there's no hiccup. Because again, carriers do tend to have whether it's this carrier grade mentality or whatever it is, they want to make sure that things work at a certain level, and their customers expect certain levels, service level agreements and service quality. So that's going to be a huge challenge of making sure that all, end of the day, works together. That's going to be a big challenge. I'm sure keeping most people up at night is going to be getting that stuff working together.
It's a challenge, but there's also an opportunity. With the proliferation of SDN concepts and NFV concepts, the telecommunication industry starts learning how IT really works. And therefore, the integration of legacy equipment, which in the past has been done significantly different, it was very hand-traded, it was very tailored, through relatively simple wrappers. I'm not saying it's as simple as just writing a wrapper, but some of these techniques of how legacy methods are included in IT systems, even that is making it into the telecommunications industry. And therefore, support of legacy, even that in the future, I believe, will change compared to how we've done this in the past. And so that the integration of legacy will happen faster than some of the methods we've used in the past for doing that.
Sure, makes sense. And you kind of mentioned too, obviously the move towards 5G. I mean, it seems like the timing of this move towards virtualization really aligns well with the move towards 5G. I mean, obviously 5G is still trying to get standards on that pinned down, but it seems like a lot of the talk around 5G is going to involve virtualized platforms using SDN and NFV and things like that to really be able to help manage what's going to be a lot of new services and new network deployment models, and whether it's small cells or IoT or smart cities and things. I mean, it's such a proliferation of where wireless is going to go, where telecom is going to go, that you need to have virtualization in place, automation in place to kind of handle what's going to, all this new input coming in. Obviously, you guys are doing quite a bit of work on that. I mean, what's your view on how that timing is working and the importance of virtualization towards 5G? I mean, you mentioned a little bit already, but I guess the overall view of the importance of these two really working together, both in the field, but also in a timing perspective too.
Well, if you look around, particularly both in the network space and the radio access network space and the core network space, virtualization really is present everywhere in 5G, and that's either because of relatively straightforward propositions like Cloud RANs, but even some of the service requirements are really hard to imagine to be tackled without virtualization. Latency. How am I supposed to tackle 5 millisecond latency if I have to go around the entire globe? You don't. Bring the server closer. And that's the whole aspect we're even trying in the IP over ICN story bringing surrogates closer to end users, and that's where the routing simplification story comes in. Once you start doing this, you get your virtualization close, to your base station. Obviously, the routing simplification has to work at the same time scale as the virtualization relocation happens. But it has to go all hand in hand to bring the resources where they are needed, and that's as I said, everywhere in 5G you won't get that done. Perceived coverage of 100%, essentially, in the end, it means you're bringing coverage to people where they're needed in order to turn down resources where they aren't needed. All of that is a virtualization story. It has to do with computing resources moving about, and it needs to be done. Standardization efforts for that haven't even kicked fully loose. A lot of these standardization bodies still are in study phase, and they're trying to understand the concepts that are out there. They're trying to feed our solutions in the IP over ICN space in these discussions as well, because it feeds into the whole discussion of routing simplification. There's a lot happening, and I think if there's anything, there are relatively good milestones at the moment that kicks a little bit towards not only standardizing, but also building and trialing. We have the Olympics coming up, 2018, 2020, which obviously do set milestones for the industry to showcase solutions that can be shown at scale in different environments. We are working in the UK with partners to showcase solutions in a city scale and a smart city scale to give a 5G label to what we are doing, and emphasizing that it's not just about making the pipe bigger, it's about offering really service experience and inclusion of vertical sectors that haven't been included in 4G so far.
Yeah, that's a great point. Yeah, that's a good point about 5G. It is not just going to be a bigger pipe, which obviously gets a lot of the attention. But the more important part of it is this, I guess, the smartness, if that's the right word for it, but just how much more intelligent the network is going to have to be. And that's going to be the huge challenge, because that is going to tie everything together. I mean, when you talk about latency, when you look at smart cars, for instance, or connected cars, I mean, latency there has got to be next to nothing for that to really work. And those are obviously moving vehicles, and they're at high speed, and just the thought of that alone seems like a frightening challenge to kind of get all of that working together. So to get all of that playing together at some point in the future, that's going to be, obviously smart people are working on this, and at some point they probably all come together, but that seems like a huge, huge challenge.
But the latency part is one of them, but the other one is also the end of over-provisioning. If you want to get a faster pipe, over-provisioning, it's not the way to go anymore, and particularly not in the core network, right? And I recall an interesting in the context of building management, an interesting discussion we had with a data management provider, platform provider, to talk about their newest, enterprise-grade data management platform, and beautiful use cases in a building management scenario where the building from a healthy state, which has fairly no data rate. So the building essentially tells you, I'm okay. Mm-hmm. Suddenly 1 or 2 floors, catch fire, the building isn't okay anymore. And you switch from one second to the other, from I'm not okay, meaning I actually have to record gigabits of video and send it out. Now, what you're doing is, if you don't properly provision, either you over-provision for the gigabit case, or if you don't over-provision, your pipe is going to explode. How do you deal with these cases in the future? And that's where flexibility comes in. I'm doing early pre-aggregation, changing from data at rest to data in motion very, very quickly. It needs to marry data management in IoT with network management that redimensions very, very quickly. And that's, again, where SDN comes in, flow management comes in, programmable flow management, but opens the pipe really, really quickly, because there's a lot of data coming down the pipe. Right? And these are use cases that today are really, really difficult to accommodate. And that's where, a lot of hope for, again, SDN, the whole aspect of routing simplification, routing changes, routing architectures lies in to make these things work. And they are, again, for building management companies, it's not about, delivering the next YouTube in 4K. That's not really what they care about. These are cases they would have liked to do years ago. They're all done in proprietary systems. They would like to do them over standard systems, but these are the requirements, and they're very, very difficult indeed to fulfill.
Yeah, that's a great point. Yeah, whenever these new use cases are always brought up, I've read quite a few in the past, but every time I talk to somebody, they bring up a new use case, and it's like, yeah, that's a tricky one too. You see so many things out there. It's like, yeah, that's a good point. How's that going to work? That's the one you just brought up. That's a great point there. You're right. Building that 1 second is just everything's fine, and the next second it's having to do all this recording of data and stuff. That's a big extreme. And yeah, you got to have that instantaneous network that can do it immediately and handle all that without falling apart, basically. So Yeah, that's another great point. Yeah, those use cases always seem to pop up, great ones like that. So, well, I guess maybe to wrap up the conversation a bit, I mean, obviously, we kind of talked about a lot of the challenges ahead. I mean, obviously, this is a big world that's changing. Virtualization is changing a lot in the telecom space. 5G is also going to change a lot of things too. As you look forward a little bit, what do you view as maybe some of the bigger challenges that need to be met by the industry I guess to kind of keep this thing moving along? Maybe a short-term challenge and perhaps a long-term challenge you see that could perhaps, maybe not trip up the process, but at least cause some pause when it comes to this continued evolution. What do you see out there, I guess, from your point of view?
I think the biggest challenge to me is a rethinking of what we understand in terms of owning infrastructure.
Okay.
So the concept of ownership that we see today, in particular in the mobile industry, I believe is severely challenged by a multi-tenant scenario where you have to integrate infrastructures that you do not own really, really quickly, essentially establishing MVNOs at an instant, right? And if you look at today, even though software-wise or technology-wise, we are at a stage where we could establish MVNOs relatively quickly, still the whole contractual obligation and everything takes days or weeks at least. And some of the scenarios we are looking at are really scenarios that essentially require, because you can't do all of these contractual obligations, a priori, where you're doing them instantaneously. And that, I think, requires some of the methods that do exist to deal with that require a rethinking of what ownership means. And it means to give up more in order to gain more. And that's, to me, a very, very crucial rethinking that's required. It's not the type of 3GPP thinking you see. Mobile operators, they are used to owning infrastructure. Yeah. And if they're not owning them, they are hosted, but they're still, in an ownership type of relationship. And that's the biggest challenge for a number of use cases that we are seeing. In the context of another EU Commission study that we are currently doing, is we're looking at socioeconomic impacts of 5G on vertical industry. We're trying to approach this study from the viewpoint of the vertical players and asking a very simple question and looking, at the 5G train moving forwards. What is it that you have as a requirement? What is it that you really need? And what are the big numbers we can expect to come out of the expectation of the vertical players, given the emphasis on vertical players in 5G? And seeing if these two things match. Is it all about, faster pipes and lower delay, or are there some qualitative characteristics that vertical players need to see but have to do, for instance, with regulation, with ownership, with the assignment of assets, if you will, but are much more important than the quantitative benefits of getting 1,000 times faster bandwidth. And these are kind of some of the stumbling blocks we are trying to identify, and that's commissioned again by the European Commission, which is obviously, as a policymaker, quite interested to understand these kind of things that are not very simple to grasp in quantitative parameters or values, if you will.
Yeah, great. Yeah, obviously, like you said, a complete rethinking of what's going to happen in the network. I mean, the first one you brought up there, obviously, telecom operators, especially mobile operators, like you said, are very controlling. They're used to having their own networks. And here in the US, at least, that's even probably to an extreme. I mean, they want to control everything. Europe and Asia, perhaps they're a little more open to sharing of stuff. But yeah, that's going to be a huge challenge to get that rethinking everything. I know, talking to some operators here, AT&T, for instance, they're very open to kind of this move towards virtualization and rethinking everything. But that is a step that will be probably a very big challenge for those guys to release some of that control. So that'll be interesting to watch how that plays out in the long term. But well, hey, Dirk, definitely appreciate the great insight on this today. Obviously, this is a technology and an industry that's moving rapidly and changing very quickly. And I know you guys do a lot of work there at InterDigital, trying to stay ahead of this as well. So we definitely appreciate the great insight today on this, and hopefully catch up again soon on the topic. Thanks so much.
Mm-hmm. Thank you very much. Thanks for having me.
Great. All right. Well, again, thanks everyone again for watching this week's NFV SDN Reality Check, and make sure to check us out again next week.
NFV SDN Reality Check with Dan Meyer is a production of RCR TV. To suggest show topics or to reach Dan, you can find him on email, dmeyer@rcrwireless.com, and on Twitter @Meyer_Dan. For more Dan, news on NFV SDN and everything wireless, find your way over to rcrwireless.com.